few weeks ago. It was a blast. Very happy to work with their US team. Yeah. Last but not least, I want to welcome the HackerLink team, who have perfected the quadratic funding mechanism protocol in the past few months. HackerLink is one of the teams that conducts most advanced service research, how we can bring a better quadratic funding to the community. So welcome, Eric.
Thank you, guys. Yeah, so very excited to see all the amazing projects from our grant. And I think, so I think we have 2 days to go. Now we have a leaderboard listing of the 8 projects. I think 2 projects, 1 project is not here today because they're in Africa. They're building a polling application for African politics, which is super interesting. And if you're interested, you can go to the HackerLink platform and look at the build of the detailed information are there. So today I'm going to introduce the new version of the quadratic funding protocol, which is solving some of the existing problems of the original version of quadratic funding, which we call it the Quadratic Funding V2 protocol. So over the past 1 or 2 years, both HackerLink and other platforms like Bitcoin and the CLI fund, they are experimenting quadratic funding. So mostly people are using the algorithm introduced by Vitalik Buterin. But actually the idea of quadratic funding was originally from quadratic voting, and the current version is kind of like a combination of different thoughts from history. Like quadratic voting is like an improvement of the traditional democratic voting system, but also you have matching fund, which was originally invented by Benjamin Franklin, who raised funding to build a first university in the world, which is currently the Pennsylvania University of Pennsylvania. So what is missing from the quadratic funding V2 protocol? Basically, we have a few problems. We have the CPU resistance and the identity problems. We have the equality considerations, because when you have quadratic funding, you are basically powering the influence of the vote, which will make the inequality problems more severe. So if you look at the original paper, so the green part is the contribution from the donors, but also the yellow part is the matching fund, which we call it the support area. So when matching fund is distributed, it's distributed according to the support area. So because the support area is kind of a quadratic function of the total contribution, so the equality problem is more severe in quadratic funding than original like 1 person 1 vote funding. And also we have collusion resistant problem, and also scalability and adoption problem. So I'm going to go through this one by one very quickly. So if you look at the very early stage QF round, for example, this is the Binance Smart Chain Quadratic Funding Round 1, happened earlier this year. And if you look at the leaderboard, it's pretty interesting because there are several patterns highlight the quadratic funding. So first of all, so at that moment we got like 300 BNBs for for the matching fund, but the community contribution is far beyond the matching fund on the Binance Smart Chain. So other people were donating to the open source project. So I would say there were some CBO attacks, but there were also a lot of community contributions. And if you look at the rank, so for example, the Blind Box project received a lot of BNBs from community from the community, but actually they received less subsidized matching from the matching pool. So why is that? So probably it's because less people contribute to this project, or some big donors donated some very large amount of BNBs, and that resulted a net less support area, and then it received less fund from the subsidized pool. But in general, it's a way to have the community contribute to a list of projects from certain ecosystems, which can be considered as public goods or common goods. And in the end of the day, we can distribute the subsidized matching pool based on the donation from the community, which is also the voting result. So, so given all these problems, we are solving them actually one by one. So the first problem is a CBO attack, because with on-chain voting, you actually, so some people will be able to forge identities. But actually, speaking of CBO attacks are not only happening in quadratic funding or any on-chain or decentralized governance. CBO attack happens everywhere in the world, in the democratic system, in elections, voting, etc. But in the traditional world, identity is a big problem. So the way the governments or centralized organizations solve these problems is to provide a centralized identity solution, for example, passport or other ID. So with on-chain governance, we can still do centralized ID, but it might be harder to incorporate the centralized ID systems into a decentralized governance application. The reason is that the centralized ID, first of all, they're not totally secure, but also it's pretty hard to fit that into a workflow of any decentralized governance protocol. So I think similar things, if you take a look at eSign, eSign is like a decentralized e-signing protocol, and if we have a decentralized application, for example, we have a auction protocol, we want to have user KYC or user identification or user signing, we better integrate the workflow of another decentralized application into our decentralized application. But if we do a centralized application, it's going to be harder and more have more exposure to attacks. So how can we do this? So first of all, if we want to have a decentralized solution, we recognize that CBO attacks is actually a cost problem. So later we designed a ID system. It's called Dora ID, and it's a decentralized identity and staking framework. And the goal of Dora ID is to provide a general decentralized autonomous DID framework in the Dora factory infrastructure, so that we can allow any organizations or pilot developers or users to stake token and then get provided a decentralized ID. And and later we built up this system, and then now it's available online. So there is a staking game incorporated into our Quadratic Funding V2 protocol, which is so the round owner, like people who are running the Quadratic Funding round, they can develop a mechanism based on DORA ID and addresses with certain staking requirements. They can have more weights when they are voting or donating to the public goods or open source projects. So in this way, we highly increased the cost to conduct any civil attacks, and the concept is implemented into DORA ID, and we're actually using DORA ID in our newest Quadratic Funding round. So if you're interested, check out the URL, and also DORA Factory's Medium platform, and you can just go over DORA ID for the framework. So previously we were actually doing post-round analysis, which is super important. So every Quadratic Funding rounds, after the round ends, we conduct post-round analysis. So it's data-driven, it's based on pattern matching. So we have done that for BSC, Filecoin, Solana, and many other rounds on HackerLink. As you can see, many ecosystems are running Quadratic Funding rounds on HackerLink. So basically, we're doing post-round analysis for most of these rounds, and the result is satisfactory because most of the civil attacks has clear pattern, and we have those patterns, and we have a certain closed-sourced model, and we do pattern matching after the round ends. So actually, every time we do that, we can distribute the matching fund pretty fairly. So this happens after a few rounds initially heavily attacked. So what's the problem of post-round analysis? Basically, we can identify three problems. The first problem is closed source. So it relies actually on our centralized analysis after round. So it brings in certain elements of centralization. Secondly, it's pretty time consuming because sometimes there are a lot of votes coming in, and our scripts must scratch all the votes from the blocks, and sometimes that's very time consuming. That takes a few days to analyze, so the results will be delayed. And lastly, there might be loopholes in our analysis, and there might be undetected patterns. So it's not a ultimate solution. And currently we are combining DORA ID with post-round analysis, but we're also improving DORA ID for anti-civil staking mechanisms, and with better anti-civil staking, like decentralized anti-civil staking mechanisms, we can eventually we might be able to eliminate post-round analysis. So the other problem of quadratic funding is the inequality problem. So because the fact that I described earlier, the support area is a quadratic function or a power function of the votes. So if some project get a vast community support, and that will result a even bigger inequality from the round, which means the top projects will receive a lot of funding, and the medium results will have the projects in the middle and on the lower range will receive less funding. So the idea of solving the inequality problem is from the progressive tax system, which has been working during the past century, and it has reduced inequality of the post-World War II worlds greatly, and even for now, it's working pretty well. So we are borrowing this idea and developing the progressive tax system into quadratic funding. So the way we are developing a progressive taxing on-chain governance system is to make it programmable, actually. So we can add the algorithm into our protocol and make the algorithm dynamic, so that a progressive tax can be charged once each vote is conducted. So we have an article describing this mechanism on its research forum, and basically what we're doing is to define a tax ratio, and the tax ratio is actually changing every vote. So every vote, so after every vote is casted, we can calculate the tax ratio of a certain project, and the tax will be charged, and it's going to be contributed to a common pool, and after that we can distribute the common pool to all the projects, so we can eliminate certain level of inequality. And the result is still being experimented, and we are deploying the algorithm into the Quadratic Funding V2 protocol. So the new rounds, including Polygon grants, which is happening in 1 day, and the Platon grant hackathon, we are experimenting progressive tax system in the QF. So the last problem is scalability. So one problem we haven't been tackling is the collusion problem. So first of all, collusion also is not on-chain specific. It's a real world problem. So there is something called ballot harvesting. This is happening, I think, in most of the elections and democratic system, but also in non-democratic systems. So collusion is like a common problem of all time. So it's actually debated quite a lot in the Ethereum research community, and one of the solutions is called the minimum architecture of anti-collusion. So there is a minimum anti-collusion infrastructure. So it's based on a operator which operates centrally, and all the votes will be casted from the users, but encrypted with the public key from the operator. So when the operator receives the public key, the operator decrypts. When the operator receives the votes, he or she will decrypt the voting results with her private key, and the result will be exposed to the operator. So the operator does certain statistics and gives results, but also provide zero knowledge proof, just proving the result is accurate and truthful to the community, and so on. So MACI is one of the solutions, but it might be a solution that is too strong because it eliminates all the social aspects of the voting process, and it's kind of making the process boring. So what we need to do is actually to find a middle ground where we can actually keep the social aspects of the quadratic funding rounds, but also reduce collusion in certain degree. Because in the end, the community is donating and the community is voting. So you can't just say that every promotion is collusion, but we have to define collusion in a very specific way and use certain zero knowledge technology to prevent large scale ballot harvesting behavior. So collusion is not not something we have been incorporating to our new protocol, but we are sponsoring certain groups doing some research, and we expect to have something interesting coming out in the next few months. Lastly, I would like to talk about quadratic funding rounds beyond crypto. So with on-chain governance, actually, we can do a lot of interesting things. So quadratic funding can be available to a larger audience. So something we can think about, for example, DAOs. As we can see, even today, we have DAOs that are not totally crypto native. We have quantum developer DAOs, and we have event organizing DAOs. And DAOs can be very general, and they can be beyond crypto. So quadratic funding can be one of the best ways for DAOs to distribute funding to the public goods or common goods the DAOs are granting or supporting. So we can imagine there can be a lot of non-crypto DAOs using quadratic funding mechanism to fund public goods. And secondly, we have nonprofit organizations. And recently there is an article from our community talking about a new mechanism called continuous common good funding, or CF. CF is like a new funding mechanism based on bonding curve to support common good projects or nonprofit organizations. So you can imagine all the nonprofit organizations use QF, and also governance or corporates can use quadratic funding to help with decision making. So if we want to make quadratic funding scalable and beyond crypto, we need to think about the scalability problem. And in the end, we need to propose anti-CBO solutions and anti-collusion solutions, and also ways to mitigate inequality in the voting system so that we can actually scale quadratic funding. We just deployed our quadratic funding V2 protocol last month, and we're now experimenting of the mechanisms in real QF rounds on HackerLink. So just check out all these quadratic funding rounds and hackathons on HackerLink, and you will see how the new mechanism and the QF work in the real setup. Yeah, so that's my presentation today, and if you're interested, just join us on GitHub and maybe contribute to our code base.
That's great. Yeah, our team has been working hectically on improving quadratic funding to our community, more interesting features will be added, including discussion into privacy, how we can integrate privacy into voting on QF in general. So yeah, we're very happy to research into it and bring more advanced products to the industry, to our hackers in the future. So yeah, that's the last of the presenting projects for today. We originally scheduled a discussion panel where we want everyone to discuss more about their